Hi, I'm gonna do a little short video for you here on how to compute break even for the stuff that you're gonna find at the end of your handout, and I will actually make sure this is posted as well to Blackboard. It'll be called the Chapter 7S handout. We're gonna start out with a pretty simple problem, and hopefully you'll find this super helpful. Okay, so when we look at a problem like this break-even problem we have in front of us, we're going to want to take a look at some basic information. And when we look at this problem, we see that we've got the various pieces of information given to us. For example, we've got price per unit that we're going to need. We're going to have X, which is going to be the number of units we're going to make. We're going to have total revenue. We need the fixed costs, the variable costs, and then of course we can compute the total cost. So to start out the problem here, you can see I have a little example. Example is that we have this operation that has fixed costs of $10,000. So let's just go ahead and write that down right here. Fixed costs equals 10,000. And just to be consistent, you'll notice up here I have F, and then I just use FC. So FC is going to be equal to F. You know, they're both fixed costs. I think the textbook uses just F, but I learned FC, so I tend to use the C. The second piece of information that's important is variable costs. So in this case, variable costs are going to equal $1.50 per unit and the 75 cents per unit for material. So we're going to add $1.50 plus 0.75, which is going to give us $2.25 for our variable costs. And again, variable costs up here is V, and I'm using variable costs is going to equal variable. So now that we know this, we can easily compute the break even in units. So let's go right up here where we have this formula. We're going to take the fixed costs, which we know are 10,000, and we're going to divide that by price, which it's stated here is $4, so it's going to be 4 minus 2.25. When we run those numbers through our calculator, we find out that would be 5,714.29. We can then calculate the break-even in price by following this formula that we have listed here. So we'll put a line and we'll go ahead and do the break-even in price. So we've got the same thing, 10,000 divided by 1 minus V over P. So variable costs, which are $2.25, divided by 4, which should give us, I'm going to write it down here, 22,857.24. 22,857.24 cents. So this is our break even in price, BEP, and then the dollar sign. That's normally what I put. And then this one here is our BEP in units. Hopefully that makes some sense to you. So now we're going to go on to the next page. So now on this page, we're doing something similar in that we're going to do break even in price and in units, but we also want to take a look at which process might be better. So I'm going to pause right here, and I'm going to calculate the break even in price and break even in units for the beginning of this problem written right up here, where we have the fixed cost of $5,000, $1.50 per unit in variable costs. And I'm going to go ahead and calculate that out here. I suggest you doing it on your own. You could, of course, just continue watching and the numbers will appear there. Because I just explained this, so just to kind of review that. And then I'm going to actually move into doing the second part and give you a little more explanation there. Alright, so you can see I've computed it as 3,333 units and $10,000. So this is the BEP in price. So in dollars, we need to take in $10,000 to break even. Now, what I have below here, your handout is going to be slightly different than mine. I've changed this bottom part just a little bit. I'll tell you why in a second. But basically, we can compute the break-even point or not the break-in, we can compute the profit for various levels of productivity. So for example, if we use the Allen shop and we produce 1,000 units, of course we know we're gonna not be profitable, we're gonna lose money, it'll be negative. If we produce 5,000 units, well then we should be running in the positive. So if we wanted to calculate that, we could just put that right in here. So we would do P price, excuse me, I don't want to write that there, I want to just have actually the price. So that's going to be for $3, which is the price, times, we're going to start with 5,000 because we know 1,000 is just too low, minus, so that's the total amount of profit we're going to take in, but we have to back out of that the fixed costs, which are 5,000, plus the total number of units that we produce, which is also 5,000, times each unit we produce costs us $1.50. So we have to back out of our total profit this cost here. So you can see I calculated it out and I get a positive 2,500. And then following the same process, we would do this for... Okay, so I'm really sorry, but I couldn't get my tablet to work anymore. It just stopped working, so I had to switch to this. So I rewrote everything here. So you can see that these are the various profits at the different levels. So we talked about all of that. It's all written here. And then down here we were doing the switching costs when the other one stopped working. So if we plug everything in, so I had gotten to where I showed you that this was 5,000 plus $1.50, and then we're going to solve for X. So when you take 5,000, subtract it from 7,500, you get 2,500, and then you subtract 1, you get 0.5, and 2,500 divided by 0.5 is going to give you 5,000. So 5,000 represents the number of units that are sold, and it is worthwhile to switch between the less expensive and the more expensive process from 5,000 to 750. So we can also graph this relationship. So the first thing you want to do is you want to do some calculating. So you could set it up the way I have, where you've got 4,000 units sold with the Allen choice, and so then you have a profit of $1,000, and then you have the second choice for the Allen is 12,000 units sold, and then you can see you have a profit of 13,000, which is just from the previous page. And then down here we have choice B, so the Belfast, or the Belton I think was the name of the place. So with this, we have the choice of selling 4,000 units, then we make a profit of $500, and selling 12,000 units, there we make a profit of $16,500. Notice this is larger than this, so we are making a larger profit when we use this choice B. But what we're interested in is sort of how to graph this, and so what I did here was I just drew out a graph. So I've got a line down here that's the units sold. I got 4,000, 6,000, 8,000, 10,000, and then up here is profit, and then I just graph my two lines, right? So here are my points that I made for when if I sell 1,000 units. I kind of stuck them down here low on the line, and then you can see that the line kind of crosses at 5,000. So it's the same as doing it on a piece of paper, if you will, but I couldn't do it on a piece of paper, so I had to do it here. So I hope this helps. I hope it's not too disjointed. I'm really sorry about the tablet not working. Please try doing problems 7, 9, 7, 10, 7, 11, because those are problems that apply the same sort of skill. Sometimes it can be difficult to get all the equations set up, but once you have it set up, it's nice if you can graph it so you can actually sort of see where the switching point is. So I hope this helps. I hope it's not too disjointed. And again, I'm very sorry to miss class this week. So I hope it's helpful. Thanks. Have a great one. Bye.